All right, today we're pulling back the curtain on a truly fundamental mystery in physics. We're talking about a hidden force, one that connects something as simple as an electrical wire to the powerful magnetic fields that, well, basically drive our entire modern world. I mean, really think about it for a second. You flip a switch, a current starts to flow through a wire, and bam, suddenly this invisible force field just appears out of nowhere, all around that wire. How on earth does that happen? It seriously feels like it should be magic. Well, spoiler alert, it's not magic, but it is one of the most elegant connections in the entire universe. You see, this isn't just some random thing that happens. There's a very precise rulebook that spells out exactly how electricity and magnetism are tied together. And here's a wild thought for you. Modern physics actually sees magnetism as just a side effect of electricity when you look at it from a different frame of reference. Pretty mind-blowing, right? And that rulebook, that set of instructions we've been talking about, well, it has a name. The Biot-Savart Law. This is it. This is the answer to our big question. It's the key that lets us predict, calculate, and most importantly, harness that magnetic force from any electric current. Okay, so here's the formal definition. And I know, it sounds a little dense and academic. It's an equation that basically describes the magnetic field you get from a constant electric current. It connects that field to things like how strong the current is, which way it's going, and how close you are to the wire. But hey, don't let the formal language scare you off. We're going to make this way more intuitive. In fact, let's just forget that textbook definition for a minute. Instead, I want you to think of the Biot-Savart Law as a recipe. Yeah, a perfect, super precise recipe for cooking up a magnetic field. And just like any recipe, all we really need to do is understand the ingredients. So let's ask the obvious question. What's in this magnetic field recipe? Well, the law itself is written out as a mathematical formula, but don't panic. Just think of that formula as our list of ingredients and the cooking instructions all rolled into one. Let's break it down piece by piece. Okay, there it is. And yeah, I get it, seeing a formula like this can be a little intimidating, but I promise we are not about to do a bunch of complicated calculus. Nope, we're just here to understand the big idea. You see, every single part of this equation is just one of the key ingredients in our recipe. The only thing that matters right now is knowing what each of those little symbols actually mean. And it really all boils down to three key ingredients. First, you've got the current, that's the I. Super simple. The more current you have, the stronger the magnetic field gets. Easy enough, right? Second, there's distance, the R. The field gets weaker, and it gets weaker fast the farther you get from the wire. Makes sense. And finally, and this is the really cool part, you've got direction. The actual shape of the wire and where you're standing in relation to it, that determines the shape of the magnetic field. For a dead straight wire, this recipe tells you the field will form these perfect circles around it, which is exactly the kind of motion you need to make an electric motor spin. So, there you have it. That's our recipe. But the real fun starts when we actually start, cooking with it. Let's take a look at how this one elegant little law becomes the powerhouse behind so much of our modern tech. And I'm not kidding. This law isn't some dusty old thing in a textbook. It is everywhere. That electric motor in your blender? That's Biot-Savart. The loudspeakers playing your favorite song? Yep, that too. Those incredibly detailed MRI scans at the hospital, the hard drive storing all your photos, even massive particle accelerators. Every single one is a direct result of us using this recipe to create and control magnetic fields on demand. And what this all gives us is something amazing: control. Just look at the difference between a simple electromagnet, which is just Biot-Savart in action, and a regular old fridge magnet. With the electromagnet, we can turn the magnetic field on and off just by flipping a switch. We can make it stronger or weaker just by tweaking the current. We get total, complete control. And that control is the secret ingredient that makes almost all of our modern technology possible. Okay, so let's pull back and look at the big picture here. Why does this one little law, figured out way back in the 1820s, matter so much to us today? Well, because it's so much more than just a formula on a page. It's truly one of the fundamental pillars holding up our entire technological world. If you take one thing away from this, let it be this. The Biot-Savart Law gave us the blueprint. It's the bridge that connects the invisible idea of an electric current to the very real, very powerful magnetic forces that spin motors, store our data, and even let us see inside our own bodies. Seriously, without this law, the world we live in today would be completely unrecognizable. And all of this leaves us with a pretty fascinating question to think about, doesn't it? I mean, look how far we've come just by understanding the magnetic field from a simple little current. So as we keep pushing the boundaries in materials science, in quantum physics, what's next?
What new, incredible applications are we going to unlock? What's the next chapter going to be in this amazing story of electromagnetism?